Today we're going to learn the segment addition postulate. And the segment addition postulate is a fairly basic, easy to understand postulate that says if I have two line segments, a line segment would be a line that has two ends that are next to one another, then the entire length of those line segments, we'll say in this case I'm just going to use numbers, the entire length of them is equal to the sum of the length of each individual one. So that's the segment addition postulate. If the first segment is 3 and the second one is 7, 3 plus 7 is 10. So it makes sense that the full length is 10. We're going to tackle this both with images and then also without images. So here we go. We have two segments, AB and segment BC, and we know that the sum of the two of them is 7. If BC is 6, then we are able to conclude that AB is equal to 1, because 1 plus 6 is 7. When we write a line segment length, we would write AB. If we were just referring to the geometric shape of the line segment, that's the symbol for the geometric shape. So this is a shape, this is a measurement of the shape. In the second one, we have line segment QS is 7 units long, and line segment RS is 4 units long. Therefore, line segment QR must be the difference between the two. What plus 4 equals 7, and that is a value of 3. Continuing on, in the next case we do not have diagrams. Instead we're just given the information, and we're told that A, B, and C are collinear. That means that they exist together in a line. In this case A, B, and C are collinear, or QRS is collinear. So A, B, and C are collinear. Point B is between A and C. All right, just like that. Find the lengths indicated. So they tell us that the length AC is 6 units. So if we were to diagram this out, A, B, C, and they tell us the full length of the segment AC is 6 units, and they also tell us that the length of the segment BC is 1. Now obviously I have not drawn this to scale, but the numbers tell us the measurements, and we want to find AB. So the segment addition postulate says AB plus BC is equal to AC. And so there's our symbolic notation for the equation that we're to solve. AB is our unknown, so I'll leave that as AB. BC we know is 1 unit, and we know that AC is 6 units, so that's substituting in our knowns. And then we use algebra to solve. If we subtract 1 from both sides, we get AB is 5 units. Pretty straightforward. We don't necessarily need to have the drawing, although sometimes having the drawing provides us an easier way to wrap our minds around this problem. So in the next problem I'm going to do it without a drawing so you can see how that works out. Again, we have the same setup. A, B, and C are collinear. Point B is between A and C. So symbolically AB plus BC is equal to AC. And then we're just going to plug in our knowns and our unknowns. BC is 8 units. AB is 4 units. What is AC? Here we're just simplifying the left-hand side of the equation, and we get 4 plus 8 is 12. So the length of the full segment, AC, is 12 units. Now we're going to move forward with this. Rather than just using simple numbers, we're going to move into the arena of having variables and applying some algebra into this. All right, according to the segment addition postulate, I can write that segment HI plus segment IJ is equal in length to segment HJ. And then we're just going to substitute in the values for each of these line segments. HI is 2 units, IJ is 2x minus 4 units, and HJ is x plus 3 units. And now what we have is a linear problem. We learned this in Algebra 1, combine like terms and solve for x. So on the left hand side I just have 2x, 2 plus negative 4 is negative 2. Then we're going to continue combining like terms. We're going to subtract x from both sides. Get x minus 2 equals 3. Add 2 to both sides. And we get x is equal to 5. Good mathematicians check their work along the way. It helps us understand that we're doing things right, so we're just going to go ahead and substitute this 5 in and see if we get a true statement. Is 2 plus 2 times 5 minus 4 actually equal to 5 plus 3? I took the x's and I replaced them with 5's, and we're going to get 2 plus 10 minus 6 is equal to 8. Not 10 minus 6, 10 minus 4. Simple math mistake there. Oh. All right, 2 plus 10 is 12. 12 minus 4 is 8. And we get 8 equals 8. So it checks out. Excellent. Okay, we're going to do the same thing on the next problem. Again, we use the segment addition. Always write it symbolically first. KL plus LM is equal to KM. Then we can substitute in our known values. KL is 5x minus 2. LM is 2x plus 3. And KM is 15 units. If we combine like terms, 5x and 2x is equal to 7x. Negative 2 and 3 adds up to 1. And move through solving the problem. 15 minus 1 is 4. Divide both sides by 2, or by 7, to get an answer of 2. So x is 2. And again, we should check to see that we have done this problem correctly. 5 times 2, subtract 2, plus 2 times 2 plus 3 is equal to 15. 10 minus 2 is 8. 4 plus 3 is 7. 8 plus 7 does equal 15. So it checks out. Of a similar relation to the segment addition postulate, we have the angle addition postulate, and it's, instead of being two segments being added together, what it's going to be is two angles being added together. Pretty easy to execute as well, but let's quickly go over some terminology about angles, and then we'll do a couple examples of the angle addition postulate, and then I'll have a little mini problem that you can tackle on your own. So with an angle, there's a couple key terms that should be noted. The vertex is the point where two or more lines or edges intersect. Lines or edges, or I'll even throw in here the word ray. So in this case, ED is a ray because it has an endpoint, but it continues on this way. So ED is a ray and EF is a ray. They intersect at point E, so point E is the vertex. And one of the sides is ED. Without a bar above this, this would just be a measurement, but if you're talking about the geometric shape, we add the bar above it. And technically, because it is a ray rather than just a line segment, we say it starts at E and moves through D. So our next ray is ray EF. Okay. Pretty easy. Just some vocab words. H is our vertex. HI is the ray that makes up one side of the angle, and HG is the ray that makes up the other side of the angle. Now, when we're talking about angles, there's actually several different ways we can refer to the angle, and we're going to use all of them in class. Sometimes one is easier than another. For example, when I look at this, there is only one angle in this drawing, and it happens at E, so it's really easy to refer to that by the vertex. Sometimes you get drawings with more than one angle, in which case people will create numbers to say various angles, like this is angle 3. If you have more than one angle in the drawing, you might count them out. You can also define angles by points that create them. So if I start at D, I go to E, and then I move to F, I've created angle DEF, which is the same as angle E or angle 3. And it doesn't matter which direction you move in, so angle FED works as well. In our second diagram, if we go through the same process, the vertex is at point L, so angle L works. Usually a single letter will work if there's only one angle in the drawing. So, number 2. Or KLM, or if we go backwards, angle MLK. So those are a couple vocab words associated with angles, and we're going to dive into the angle addition postulate, which the angle addition postulate, I'll write down here for this specific drawing. If we take the measurement of angle BCI, i.e. how many degrees is that angle right there, and we add that to the measurement of angle ICD, sorry, my hand got in the way, measurement of ICD, then we will get the measurement of angle BCD. Okay. So in this case, because I had more than one angle in the drawing, I really needed to rely on that 3-letter notation. The M here refers to measurement. So without the M, this would be the shape of the angle. And with the M, it means it's the measurement of that angle. So in this case, the measurement of angle BCI is 72 degrees. The measurement of ICD, well, that's what we're trying to find. We don't know that, so I'm just going to leave that as the variable measurement of angle ICD. And then they tell us the measurement of BCD is 132 degrees. Okay. If we were to draw this on the diagram, you could say this angle here is 72 degrees, and this angle here is 132 degrees. Our goal is to find the value of measurement of angle ICD, so we're just going to subtract 72 from both sides, and we get the measurement of angle ICD is equal to 132 minus 72 is 60 degrees. All right. Like the segment addition postulate, sometimes we do them with just numbers, and sometimes we do them with the equation with variables. So let's construct the diagram, or use the diagram to construct our angle addition postulate. Measure of angle QRC, that's this small one right here, plus measurement of angle CRS is equal to the total QRS, so the measurement of angle QRS. And then we want to substitute in our known values. So find QRC, that's our unknown. QRS is 13x plus 10. Whoa. I wrote that down on the wrong one. QRS. QRS is 13x plus 10. And QRC is 3x minus 5. And CRS is 115 degrees. There we go. So we know that QRC is 3x minus 5, but we don't know exactly what that is because we don't know what x is. So we're going to use this equation to find x, and then we can substitute that back in. So combining like terms, on the left-hand side we get 3x plus 110 degrees equals 13x plus 10 degrees. If we subtract 10 from both sides, we get 3x plus 100 degrees equals 13x degrees. And then if we subtract 3x from both sides, we get 100 degrees equals 10x degrees, and therefore x must be 10 because 10 times 10 is 100. Now our goal wasn't to find 10. Remember, our goal was, goal wasn't to find x, our goal was to find the measurement of QRC. So the measurement of angle QRC is 3 times 10 minus 5 degrees, or 30 minus 5 is 25 degrees. Fell off the camera. Okay, that is the notes. There's a formative assessment I'm going to post up here for you to try out doing one of these on your own, and then after a brief moment I will put in the key for that. I encourage you to pause the video now and try working through that on your own, and then I will display the key. All right, pretty straightforward segment or angle addition postulate. We took the first angle, IJA, added it to the second angle, AJK, to get the total angle, IJK. There was no variables in the problem, so it was pretty much arithmetic from there, and we subtracted 75 from both sides and got the measurement of angle AJK to be 70 degrees. Thanks for watching. Have a good day. Be sure to comment, like, subscribe, hit that bell for notifications.